Good day, everyone. My name's Peter Botha, and I'm the Linux Technical Manager. And today I'll be speaking to you about Linux DevOps. Firstly, we'll just see what DevOps is exactly, and then how we use GitLab to implement most of the DevOps practices for Linux. And we'll conclude with an overview of our development architecture and then end the session with questions and answers. So what is DevOps? It basically refers to a set of best practices between development and operations to speed up the development lifecycle using continuous integration and deployment. And DevSecOps is just a term to include security into this process and to focus security not only in your operational environment, but also in the development stage, to do security scans, vulnerability testing, but also monitor your deployments, basically to have a centralized visibility and view of everything that goes on during this process. So Linux has chosen GitLab to implement their development environment. While GitLab is a full-featured source control system, like many others out there, one of the things that really make it stand out is their auto DevOps solution. It really provides a lot of functionality with minimal configuration and is very polished and gives us the opportunity to really implement all of those best practices that we just spoke about in the previous slide. Not only does it give us the opportunity to do a lot of things automatically, but also gives us complete control. So when we need to dive into the details, we have that function available, and we can do that through their YAML files. The way GitLab allows us to deploy easily with their auto deploy solution is because of their tightly integrated solution to Kubernetes environments. And that basically gives GitLab control over your deployment environment, over your infrastructure, and allows it to manage that whole process. We'll also look at some of the analysis and reporting that's available right inside GitLab. So let's start off with the Auto DevOps pipeline. So what is Auto DevOps and what does it give you? Well, it allows you to, with a click of the button, literally build your project, test your project, and deploy it, and many other stages in between. So on the left-hand side, you can see the build process happening there, and then a whole bunch of tests being run. And these tests are all built in, except for this last one, which is your project test that you define yourself. And depending on what kind of project you have, you'll have different tests over here, and then it deploys to a staging environment. Once you're happy with the staging environment, there's a manual step to hit the play button and then push your deployment to your production environment. This is another view of an Auto DevOps pipeline, but this is for a review pipeline. So what happens here is if you branch your code into a feature branch and commit to the repository in the branch, it won't deploy to your main environments by default. It will deploy to your review environment. It will automatically create these. And again, you have the build and test stages, and you'll see there are different tests for this specific project over here because there are different code modules inside the project. But it creates this review environment for you to just see if the software works and if your project is what you expect, and then the ability to eventually stop that environment. GitLab will automatically stop your environment once you merge this code to your main branch and then deploy it to stage. This pipeline is also completely customizable. So for example, what Digital has done with the Quirk project is after the review, they have some testing that they do after the fact, accessibility testing, performance testing. Then there's the Auto DevOps cleanup again of the environment, but there's also the opportunity to restore data specifically for the Quirk environments. To manage your deployments, you have a nice overview of all the pipelines and how they've run before. And To re-execute a pipeline is as simple as clicking a button again. Just select the task, the job that you want to run, and hit the play button, and it'll run that job. And you can select a previous deployment to production, a previous deployment to review environment even, and hit that button, and it will create those deployments for you again, or rebuild the project, or whatever you want to do. Very easy to control and have great visibility of what's happening. So GitLab also gives you complete control over the CI pipeline. While Auto DevOps gives you a lot, you have the opportunity to implement whatever you want, and you do it with these YAML files. I'll just walk you through what we've done here for the research space environment. We started out with including the Auto DevOps template, which is also just GitLab CI YAML behind the curtains. And then we want to tune it a little bit. So we just disabled a few tests to speed up the pipeline. We don't want all of the tests running. We disabled the built-in Postgres support because we don't need that. We wanted to enable staging, which isn't enabled by default. And then we don't want those generated names in our staging and production environment. So what we did here was just creating a YAML template with the RS in front of our domain namespace, and then apply this template to the staging and the production steps. And this is our entire implementation for our research space project to get our CI pipelines running. A key component to get this functionality is the tight integration that GitLab does with Kubernetes clusters. And for links, we have set up 3 clusters that are connected with GitLab, Sandbox, Stage, and Production. That gives us the production staging and any other environment that we generate. And GitLab has service account on these clusters available that allows it to create secrets, create deployments, create namespaces, all of the things that are needed for it to deploy software to these clusters behind the scenes. Once these environments are then created, for example, in our research space environment, you'll see here there's visibility for everything that's available in research space. So this is the review environment, or one of the review environments rather, and these 3 green blocks are our individual pods that's been deployed there. Those are containers running in Kubernetes, and the same for the staging and the production environment. And we can easily from here just click on that block and go see logs, which I'll show you later, or open the environment itself in HTML on a new browser window over there. Even open a shell inside the container or look at some metrics. Just to show you what these environments look like that we generate. These are the generated names for the review environments. So it's our project ID plus review plus some name in front of our sandbox cluster. And for staging, we overwrote that with just RS to always deploy to the same place, the same for production. And we have nice clean names that we can always use and deploy to. As I mentioned, we can see logs and metrics for pods, but we have implemented something special in the links environment. We included an Elasticsearch stack that scrapes all of the pods and gets all of their logs indexed into a database so that we can query it with free text search and some time range. We collect past 30 days, I think, by default for any pod in our environment. And this is a great feature. It allows you to look at logs of past pods that don't exist anymore and where the containers have been replaced, but you can compare the different logs. It really helps with debugging. And then there are some metrics available. So for example, we're looking at memory usage and CPU usage over here. Again, you can look in the entire environment or specific pods, and these are available right in the GitLab front end. Another nice feature that's available is some of the reporting features that GitLab gives you out of the box. Here we're looking at a vulnerability report. So those scans that ran in the test phase of our deployments, here they have the results of all of those scans, and they show you what vulnerabilities currently are exposed in your containers. And it also scans the dependencies, so those will come up here as well. And I think that's one of the reasons why these numbers are so high. It's just because we're including older versions of containers that still include vulnerabilities. This is another view of more or less the same report over time. So we can see that we've addressed some features over here at this point, and much fewer vulnerabilities currently. Then there's a lot of development analysis that you can see as well. So I just highlighted a few things around commits here, where you can see how many commits you're doing, and getting some averages and some nice graphs, and seeing people tend to work much less on Fridays than on Wednesdays, and interesting statistics like that. But it really gives a manager the ability to see what's going on. One very special thing that we've implemented for Linux is our custom GitLab runner. Now, a runner is the piece of code that runs to implement all of these CI jobs that you saw previously. So each of these is a process that gets started by this GitLab runner. And for us, at least, our runner runs Docker, and all of these are executed inside Docker containers. Now, this can be a very long process if you have complex tasks or a lot of tasks to do. So optimizing this process is definitely valuable. And we did two things to improve our runner's performance. And the first thing we did is we created a RAM disk where it can build and cache items. Because of the slow network storage of the virtual machines that we get in Compute Canada, this RAM disk really made a huge performance for Docker to build and to run all of the tests from. The other thing we did was we mounted the Docker socket to any container, from any container to the host Docker socket. And the reason we did that was to use the Docker layer caching inside containers as well. So if you have a Docker in Docker situation, the inside Docker wouldn't have the ability to cache anything from the outside Docker unless you do this. And this made a huge difference. Rebuilding something went down from 5 minutes to something like 30 seconds. Because of this, we don't have to download all of the images again. Right, which brings us almost to the end. This is our development architecture as you were, with GitLab.com hosting all of our repositories and the services that I just showed you, and with developers then being able to pull from there, do the development on their local machines. Also have a local environment where they can test, either with Docker or Docker Compose, or even Kubernetes locally, before they push it back to GitLab, all the updates, which then executes code with GitLab runners, building the code and then deploying it to the various different environments or clusters. Rancher is over here because that allows us to manage these clusters. It's a cluster management solution. And specifically for developers, what makes this interesting is they can control, or we can control with Rancher, the security context for all of the deployments. So we can create projects and create users that have access to specific projects inside each of these environments, so that developers, if they need to, can access containers directly inside of these environments, but still keeping it secure. So that really gives us an overview of what it looks like for a developer to create something in the Linux environment. Thank you. That is it. All questions welcome.